This is a physics problem involving finding velocities. Find the average velocity, the change in velocity, and the initial velocity. Difficulty, medium. You smash the target, sending the puck into the bell. This data represents the motion of the puck as it travels and strikes the bell. The puck travel height is 20 feet. The puck travel time is 0.7 seconds. The questions are, what is the average speed of the puck? How much does the speed decrease? And what is the initial velocity? Writing down our given information, the maximum height the puck travels is 20 feet. We have our positive and negative directions. We have our speed average formula, which is equal to the total distance divided by the total time. Plugging in the values, we get the average speed, 28.6 feet per second. I save this to the capital letter A in my calculator. Now what we're going to do is we need to find the change in velocity, or the speed decrease. The only thing that will be affecting the speed of the puck as it goes upward is the acceleration due to gravity, which is in the negative direction. Therefore, the puck will decrease in speed. The magnitude of the acceleration due to gravity is 32.18661 feet per second squared. I program this to the capital letter B in my calculator. Substituting in the values, we end up with the change in velocity, 22.5 meters per second. I save this to the capital letter C in my calculator. I underline the letter C to let myself know that it's a capital letter. Now we are going to find what our initial velocity is. So we have our average velocity formula, which is half times the initial velocity plus the final velocity. We have our final velocity formula, which is our initial velocity plus acceleration multiplied by delta time. Writing these equations, okay, simplifying and solving, we want to solve for initial velocity. We get this step by step, okay. I substituted the letter A, remember, which is our average speed, okay, for our average velocity. Okay, then I'm going to substitute VO plus A delta T for our final velocity. Okay, simplifying and rearranging, solving for initial velocity gives us, you get this equation. B has been substituted for the magnitude of the acceleration due to gravity. Now remember, the acceleration due to gravity is in the negative direction. We have rewritten this equation to minus the acceleration due to gravity. Therefore, we have minus a negative. Double negative means you add. So in our calculator, we will put 2a plus b times delta t, which is 0.7, divided by 2, and we get our initial velocity, which is this. I save that to the letter D in my calculator. Okay? To check our answer, we're going to use our change in velocity formula. Change in velocity is equal to our final velocity minus our initial velocity. Our change in velocity we found earlier and saved to the letter C. That was the magnitude of our change in velocity. Our change in velocity is actually a negative number. Our final velocity is less than our initial velocity. Substituting in the values, in our calculator we will punch initial velocity, which is D, minus C, which will give us 17.3 meters per second. And I save that to my letter E. Going back to our average velocity equation, we will plug in our values. Our initial velocity, D, plus our final velocity, and then we will divide it by 2. This should give us our average speed, which we calculated earlier as letter A, which it does. Thank you.